This is your first class, so let us understand what we are going to learn in this particular course. Welcome to the course on advanced neural science for engineers. Myself Hardik J. Pandya. I have my PhD from IIT Delhi and a short stint in Harvard Medical School for about a year and also about 3 years at University of Maryland College Park. This was as a postdoc. After joining IISc in 2017, right, the lab focus was on healthcare and advanced healthcare in particular, out of which one of the research area is on brain. And when we understand the complexity that is involved in the brain, you will appreciate how things works, how a human works, right. It's a, if you say that heart is the most vital organ, so is the brain, right. And when we understand the science behind the brain, then you understand that what are the gaps, right, that one can solve as an engineer to address some of these important critical issues. For example, epilepsy, right, seizures in another term, or fits in another term, Parkinson where you see the tremors, right. Brain tumor itself. There are EEG based platforms for brain computer interfacing. Lot of interesting stuff is going around this domain because this is the frontier which is still unknown. We kind of understand almost each and every organ of humans except brain, and the idea of this course is to make you understand what are the interesting problems, to make you understand how as an engineer you can solve some of the important gaps, to make you understand how the brain, a part of the brain works, right. We will try to understand how it works and what is the science behind it, okay. Why we are assuming that designing or developing a certain system for acquiring a neural signals and understanding the signal processing, right, studying the signals will help to issue the problem that we are studying on. So, with that, let us start little bit about what exactly a microfabrication can bring a solution to the important problems. Now, before we go into microfabrication in detail, if you see the slide, you can look at the website through this barcode, and this is my lab website. Here we have 3 laboratories, and predominantly the work that we are focusing on is on communicable as well as non-communicable diseases, all right. So, what is communicable disease and what is non-communicable disease, and whether the study of the brain, right, falls in communicable or non-communicable, right. We will look into that. So, if you understand sensor, and to fabricate sensor we will be talking on dimensions which are of few millimeter, but the feature size will range from 10 to the power minus 6 to 10 to the power minus 9, and that is from micro to nano, So, that is a scale that we will be talking about. Now, when we talk about micro to nano, you all know that human hair is, the thickness of human hair is about 50 to 80 microns, that is the thickness of human hair. So, what we are talking about is somewhere around 10 micrometers, and if you go down to nanometers, it is way smaller than even the thickness of one single human hair, right. So, we will be looking at the technologies and how to fabricate those kind of devices. Now, apart from the research area which is on brain, we also focus on heart, right. This first class I want to introduce several research area that we are working on in the laboratory. So, at the end of the course you will understand that learning certain techniques to fabricate a device or fabricate sensors per se, how it will help you to also focus on other applications as well, right. We are talking about neural science, the area which is brain, but if you understand how to fabricate the device, if you understand the technologies that are involved in fabricating a device, then you can fabricate different kind of devices for other applications, for other vital organs as well, and that is the role of the sensors, right, in different application. So, let us understand a different area that one can apply the knowledge on to solve important problems, and the first organ that we will be talking about is heart. Now, we all know that the human heart beats about 70 to 75 beats per minute, right, but if it starts pumping faster, what will happen? If it starts pumping faster, it is arrhythmia. Now, if you do a physical activity, if you run, right, then there is a heartbeat will increase, but if you when I am just delivering a lecture, if my heart starts pumping extremely faster or it beats faster, what you can say? I may have arrhythmia, alright, when heart starts pumping faster. But in certain cases heart starts pumping unevenly, and of course there is a cure for arrhythmia, and a part of arrhythmia is also called AFib. What is AFib? AFib is called atrial fibrillation, alright, where the heart starts pumping unevenly. Faster is one thing, uneven means fast, slow, fast, slow, 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 fast, fast. It is the rhythm is not there, and how and why, right. So, the reason behind heart pumping unevenly is because of the misfiring of signals, electrical signals in the heart. If the electrical signal misfires, then heart starts pumping unevenly, and that is what we call atrial fibrillation or AFib, alright. Now, to understand which region in the heart is having this misfiring of electrical signals, for that what we do? What we means clinicians, right, surgeons, they will insert a tube, okay. This tube is called catheter, and the catheter will reach the heart. Then there are electrical sensors at the tip of the catheter. So, it is a tube with the electrical sensor at the tip. When it reaches the heart, different regions of the heart they can perform electrical mapping. They understand what kind of electrical signals at which regions are arising. If there is a electrical mapping, then one can understand where exactly is the problem, where exactly is the misfiring of the signals, right. Once you understand where is the electrical mapping of the heart, that is the certain region which is misfiring or the electrical activities are non-uniform, you take out this catheter, put another catheter and ablate the tissue which was misfiring. Ablation is heating. When you heat it, tissue will die. Tissue dies, the conductivity will not be there, right. So, ablation. How to ablate this heart tissue? By using RF frequency. So, radio frequency ablation, right. Now, apply a force. So, where you have to apply a force? Because for applying radio frequency you have to touch the heart. If this is the region what I am showing on my palm, right, which is causing the misfiring of signals, the catheter has to touch this region and there should be certain force that needs to be applied so as to perform the surgery, right, or the ablation. This force ranges from 0.3 to 0.4 newtons, that means around 30 to 40 grams. The force is required in that range because that is the optimum force for ablating the tissue. If the force is more, what will happen? What you assume? If I apply a radio frequency signal and the force is more, the other region in the heart will start ablating. What we want? Do you want that? No. If the force is less, then the reoccurrence will occur, means the patient will have the same episode even after the operation is done in 2 months, 3 months because of the tissue regrowing, right. Now, there is something called transmurality. What is transmurality? Now, when we look at like this, right, it is 2D, but heart is not 2D, right. So, if I heat the tissue, like if I ablate the tissue, is tissue completely burnt, right, if tissue is completely burnt, that is called transmural effect. Do we know that, right. So, that is interesting challenging area to understand whether the heart is ablated, the region of the heart is ablated correctly or not, right. What is the transmurality? And now comes the actual problem, that means does the existing commercial catheters, which is a tube with RF, right, radio frequency ablation and radio frequency signals that you can apply on the tissue, right, this kind of catheters are available. So, the tip which can apply radio frequency, the catheter that can reach to the heart and you can apply radio frequency and you can measure the force is available. So, the question would be, if this kind of catheters are available, then what is the gap, is not it? So, if a surgeon is operating a patient and he or she can see the force on the screen, then what is the problem? If you know the force, you can ablate the tissue at between 0.3 and 0.4 Newton and that is it. The problem is that they can see the force, but they cannot feel the force. That means, if I am applying this force, right, because the catheter they operate it outside, right, and the catheter goes inside. So, you are operating it, you can see the force, but there is no haptics, there is no force, feeling of the force on the operator's hand. So, when you do not have the haptics, that is a gap that you have identified. Can you add the haptics or haptic feedback to the existing commercial catheters, right. If you add haptic feedback, then when the surgeon is performing the surgery, the surgeon will be able to feel the force. Feeling of the force while you are ablating a tissue will probably improve the way the surgery can be done. So, for that we have a collaborators from Jaydeva Hospital in Bangalore who are interested in addressing this particular issue, and we are trying to fabricate a catheter. We are successful in fabricating a force sensor with a catheter tip. We have also developed a prototype of a catheter, but when I am talking about we are developing a catheter, that means a catheter that can be taken to the next level, right, that can translate from laboratory to market. So, that is a procedure, that is a journey. Let us not worry about that right now. My point was that this is the gap, that there is no haptics, and can you have or can you integrate the haptic feedback to the existing commercial catheter. This is one of the important problem when we talk about organ, which is your heart. What is the another problem, right? So, you see there is a LVD and RVD. Okay. So, right ventricular disorders disease, and then there is a left ventricular. So, if there is a change in the LVD, that would be corresponding change in the RV region, right. If there is a change, then a doctor can predict that there will be some issue in near future. This is while the operation is done. So, can you develop a probe like a pen that I am holding here, that it touch the tissue, and can you tell there is a difference between your LV and RV, and the RV is correspondingly changing with respect to LV. From that, can you predict that your heart would get into deterioration in near future? Okay. I am just talking in extremely layman terms, so that we all understand that we are all either we are from science background or we are from engineering background, right. So, I am trying to make myself as easy as possible, so that we all can understand, right, what is the problem. So, there is a problem of understanding the change in the tissue property in the heart, LV versus RV. For that, we are developing a probe that is integrated with NIR and integrated with EIT, We will talk about what is NIR, near infrared rays, what is EIT, electrical impedance tomography, and we will see that how these two different modalities can be integrated together even for delineating the tissue in brain, right. So, when you understand how to use certain modalities for one particular disease or one particular application, the similar kind of modalities can be used for other applications as well. So, we will be talking about NIR, electrical impedance tomography, ultrasound sensors, interdigital electrodes, force sensors for understanding the viscoelasticity. So, this we will be looking at all these kind of sensors and corresponding modalities as a part of this course, and we will focus on brain when we go into depth. Okay. So, now if you see the screen, what we have talked about? We talked about heart, correct. It's because heart, okay. Now I just little bit deviated from the first point, that is communicable and non-communicable disease. So, communicable disease are diseases like COVID, right. We have been through this tough time in last few years, right, and we know that it is communicable, it can be transmitted, right. So, the infections can be transmitted communicable. The disease which cannot be transmitted, right, are non-communicable disease, again to keep it in an extremely easy way, right. So, we work both on cancers, we work on certain important communicable disease like bacterial infection called sepsis, neonatal sepsis, or we talk about COVID, right. So, we had developed certain chips for measuring the presence of the virus, right, from saliva. So, that is a communicable disease. Okay. And actually when we say virus is not like really live virus, we can take out the protein from the virus, it is called S protein and N protein, and those proteins we can measure quickly on the chip. So, there is a technique, let us not worry about it. The point is that the lab focus is on communicable and non-communicable disease, out of which right now what we have talked about is a heart disease, which is a non-communicable disease. Okay. Now, we talk about something different, we talk about trachea. What is trachea? So, trachea is a windpipe. We all breathe, right, try to breathe. Where how it goes in? Through the windpipe, right. There is a food pipe, windpipe. Windpipe is called trachea. Now, when infants, particularly we are focusing on infants, who if for certain reason are kept on ventilator, okay, then the trachea gets inflamed. That means, the windpipe gets inflamed. Now, if the windpipe gets inflamed, that means in a easier term, even and I am sure that everybody knows what is inflammation, right. But to even make it easier, you assume that you have a hollow pipe, okay, and hollow pipe is now filled at certain region with some kind of material. So, what will happen? If you flow the water through the hollow pipe and now the hollow pipe is filled with certain material at certain region, the flow rate would be different, will get affected. Same thing happens when the inflammation is there, there is a narrowing of the windpipe at a certain region, right. So, that is called tracheal inflammation, easy, right. So, what is the difficulty? The difficulty is that when there is an inflammation, then there is a difficulty of breathing, and when there is a difficulty of breathing, you know what happens. So, what is a gap or what are the gaps? The current technique of course is bronchoscopy, right. Bronchoscopy is used to understand where is a narrowing of the windpipe, requires an expert skilled surgeon, pediatric surgeon. There is something called Kirschner wire, it looks like a Allen key, you put it and different size of Allen key, it's a crude method of measuring whether windpipe is inflamed or not, right. So, can we develop a tube, again what we call as a catheter, with some flow sensors, and if I place the tube in the windpipe, when you breathe in and breathe out, the flow sensors, the rate of the flow of the wind or the air, right, we breathe in, breathe out. So, the rate of the flow of the air would change depending on the inflammation. So, you need to precisely place the flow sensor on the catheter. Second is, if the tissue whichever the in the trachea is inflamed, we need to know what is the viscoelasticity of that tissue. For that, we need to add the force sensor on the catheter. So, what is flow sensors? Second is force sensor on the tip of the catheter, right, two things. So, if I have the catheter that goes in the trachea in the windpipe, right, I have to touch the windpipe. If you see there is a hollow, right. So, you go in and you have to touch it, touch where the area is inflamed. When you touch it, means you are applying certain force, right, then you know what is the change in the stiffness, because of the force sensor. Force sensor can be piezoresistive, force sensor can be piezoelectric. We will look at both the force sensors in detail, do not worry about it. It can be piezoresistive, that means when you apply a force, a change in resistance, apply a force, a change in electricity, that means voltage, piezoelectric, change in resistance, piezoresistive, very simple. If you apply and now you have to touch the tissue, but how can you touch the tissue? Catheter, how can you maneuver the catheter? How can you move the catheter, right? You can maneuver the catheter with the help of nitinol. What is nitinol? Nitinol is called smart actuators, right. So, we will be looking at the way these smart actuators are integrated onto this tube, how the force sensor is integrated to the tube, how the flow sensors are integrated on the tube, and when you insert this tube in the trachea, how the flow, change of the flow can help us to understand where exactly the trachea is inflamed, and we can also understand the viscoelasticity, and we can also maneuver the catheter, we can move the catheter. So, there are two springs on two sides here, right, and there is a reason of using SMA smart actuators, so that when we heat, the spring will contract, right, and when you cool it down, it comes back to its original state. We will look into that in detail. So, what we have seen now? We have seen, if you see the screen, we have seen the trachea, windpipe, isn't it? The next problem that we are addressing on is on breast cancer. Now, please do remember, this is for you to understand how different gaps can be filled with the solutions by using microfabrication technology, but our interest would be on brain finally. Okay. So, I am not talking on brain right now, because I am to just cover the other research areas, and then I finally will go into the area of brain. So, the next topic that we will talk about is on the breast cancer. So, what is breast cancer? Now, there are several kind of cancer, right, colorectal cancer, there is a head and neck cancer, right? Head and neck, and then there is a, like for example, there is a oral cancer, head and neck is a oral cancer, and then you have this brain tumor, right, you have breast cancer, and so on and so forth, you have lung cancer, right, many kind of cancer. But breast cancer is the second largest cause of cancer related death in women. Okay. And you will be surprised to know that out of every 2 women identified or diagnosed with breast cancer in our country, 1 dies. Okay. Our country is India, of course, because sometimes the course the students from different countries also register for the NPTEL course, a beautiful platform that goes to many students, right. It is a wonderful initiative, I just love it, okay, because who gives you education for free, right. You only have to pay when you have to register for the exam. This is something that is awesome. So, I am sorry, sometimes I get excited because that is how the research is all about, right. And when it is when it reaches to so many students for not paying anything, that is how the education should be, right. So, you had to deal with my little bit of emotions here, but the point is that we will talk about the breast cancer. And when I said that the every second after 2 women 1 woman dies when it is diagnosed with breast cancer, is because we are not having a good awareness program, right. We talk about engineering solutions, we talk about high end technologies, we talk about a lot of things that we can make in India, we can talk about a lot of things that we can import, right. But where is the awareness? Awareness is the fundamental thing that is very important, right. Lot of women, now all my students, right, girl students here who will be registering for the program, or people who are watching around, right, would, if I ask a question that what is the screening technique to know the health of the breast, can you answer? It is difficult, right. Some of you can, some of you know, right. Now, we are fortunate to have a little bit better opportunity to study more than lot of other people. So, we assume that we should know about the screening techniques as simple as MRI or mammography, right, but still we do not know. Now, we assume that what will happen to our mothers and daughters across this vast land, they have no idea what is awareness program. Now, we are trying, when I say we, is of course the different government bodies are trying to aware people, go for the screening technique, go for the mammography, go for the MRI, right. But the difficulty there also is how to address such a large population and get into the tertiary clinics, right, or even to go to the mammography programs, right. So, there are screening camps, if you have seen screening camps, right. So, how it is generally identified? First we understand how it is identified, then when we see what are the gaps, and then we see how the engineers can help or aid by developing a technology that can be used by a clinician. So, aid to a surgeon, aid to a doctor, how we can develop a technology. But first is there should be a self examination, right. So, to check once in a month that there is no fluid discharge, right, there is no inflammation, right, and that can be easily done, right, once in a month. It is called self testing, right. So, self test is the first point. Second is clinical breast examination, means that a subject, a woman, right, has to go to a doctor, and doctor will check the health of the breast, and from there the next step is, if the region is suspicious, if the clinician feel that the certain region is suspicious, the person has to go for mammography or MRI. If still there is a image in which there is a region which is suspicious, the person is advised to go for biopsy, a needle biopsy, where you punch the needle in the region which is suspicious, and you take out a part of the tissue and you send it to the pathologist. So, for the pathologist, they will slice this tissue, right, and will give the diagnosis that whether it is cancer or not. There are certain markers to look into, right, go into depth, HER2 plus minus, estrogen, progesterone, right. So, there are certain markers which are present when for the pathologist to know whether there is cancer or not, and if cancer is there, then what is the stage of the cancer. So, this is the cycle, all right, this is a cycle. Now, there is a gap here, right, everything is well covered, right, from self examination, the clinical breast examination, to MRI mammography, to the pathologist and a diagnosis. There is a gap. The gap is the clinical breast examination. How many women, if they feel there is some problem, right, will be able to go to doctor and let the doctor get the test done, right. When you understand the statistics, it is disheartening that lot of women would not go due to several constraints. But can we make a tool that is easier for a doctor to test just with the breath of the patient, right. Clinical breast examination, you do not need to ask the woman to come to the clinic, but a tool can go to the village where there is a screening camp and just ask patient to breathe out from the air, from the breath. Can you understand, can you screen breast cancer is there or not? This is one thing. So that will change, that will have more number of subjects, right, reaching out to doctors, because now you do not have certain constraints of a clinician testing a patient, right, a subject. We do not say a patient until the diagnosis is done, right, but just a person. So, anyways, we do not get into all these details. My point is that if we make a tool so that a person can be screened, this is called screening, healthy, looks like suspicious, from the breath, it will be an interesting concept of non-invasive breath analyzer. Non-invasive, we are not invading anything, right. If you put a catheter, it is invasive, minimally invasive, because you are putting here and goes here, right. If you use a stent, right, angiography, put a stent, it is invasive, minimally invasive. It is also and part of invasive only, because it goes all the way to the trachea, but let us say a glucometer, right, just punch, and but that is minimally invasive. Non-invasive is a breath, right. So, can we have a breath analyzer, what we call as a electronic nose, that can be used to screen the patients who are likely or who are at a initial stage of the breast cancer. Now, what I said initially is that out of every 2, 1 dies, because when they come to the clinics, when the diagnosis is done, already they are at stage 4 or stage 3, right. Why? Because screening is not done at the right time. Why? Because they are not aware, right. So, awareness is the basic. Then comes the technology. Now, you understand this is a whole cycle, in which one is that you can make a breath analyzer or an electronic nose to identify a certain VOCs. VOCs is volatile organic compounds, that will be in a higher level for the patient suffering from a certain disease, in this case is a breast cancer, compared to the subjects, normal subjects, assuming that we are all normal, right, the breath content would be different. The VOC content in the breath would be different. So, can you develop such tool? That is one. Second is, when the tissue is given to the pathologist, right, I said that first is self exam, then clinical breast examination, then MRI mammography, then the region is suspicious, then the breast biopsy, right, needle biopsy, you take the tissue out, and that small tissue that is sent to the pathologist, can you quickly get the half of the tissue, because not complete tissue is ever used, okay, it is always saved in the tissue bank, it is kept in the tissue bank. So, can you take this small amount of small chunk of tissue and can tell quickly whether this is cancer or not? How? By using a technique that we have developed called electrical, thermal and mechanical, ETM, right. Using these 3 modalities, electrical, mechanical and thermal, can you identify whether the tissue is normal or tissue is a cancerous tissue. That is another thing that now we are talking about. The next aspect would be that if there is a cancer, after the pathologist says, this is histopathology, guys, okay. Histopathology, that means the tissue, understanding the tissue and understanding what are the markers present in the tissue is the histopathology, and that is the gold standard. Gold standard means across the world this technique is accepted, this technique is considered a right technique, or not right technique, I should not say term right, but this technique is a gold standard, means this is accepted across the world as a technique by which one can say and one can guarantee that there is cancer or not. Of course, this technique has a limitation. For example, there is something called triple negative breast cancer. Triple negative means all the markers that the pathologist assumes that should be there, or certain markers to be there, all three are absent, but there is cancer. What do you mean? All three biomarkers are absent, but still there is a cancer, triple negative breast cancer. Can we identify that triple negative breast cancer with the tool that we have developed based on electrical, thermal and mechanical modalities, and can tell the can give the diagnosis, so that we save those patients who have triple negative breast cancer, right. So, 12% of the breast cancer cases are triple negative, huge number. Okay. Now, once a pathology examination is done, and if the report comes as positive, the person has to go for the surgery, right. So, when the surgeon operates, surgeon will remove the tissue, and based on the preoperative MRI, the region, the data, the images, the analysis, right, he or she will remove the part of that particular breast, right, which is the suspicious part. Now, it is not any more suspicious, it is a cancerous tissue, because we have gone through the gold standard and we have the images, right. So, you remove it. Removing is called resection, okay. When you remove it, now after you remove it, how you know there is no more cancer left, right. So, the tissue is sent frozen section, again the pathologist look into that and they get back to the doctor. What I was trying to understand, and after discussing with a few of my clinical collaborators, what we understood is that if we can have a tool, a pen, a probe that can be used, or that can be given to a clinician, to a surgeon, or onco surgeon or breast cancer surgeon, and during the surgery, if the surgeon can touch the tissue during the surgery and can tell whether there is cancer or not, right, that will be really helpful. So, we can develop this probe, we can develop this pen like structure by integrating the electrical modality or mechanical modality or thermal modality or NIR or ultrasound, or integrating either or multiple modalities into the single probe. And based on the study that can we do on ex vivo, now suddenly a new term, right, what is ex vivo? See, there are three terms that you need to understand. The first term is called in vivo, INVIVO. In vivo is within the body. Second is ex vivo. Ex vivo is outside the body. Okay. That when we understand inside the body, in vivo, experiments inside the body, for example, ablating the tissue, in vivo. Ex vivo is when you take out the breast biopsy tissue and understand the properties of tissue, ex vivo. Third term is in vitro, INVITRO, in vitro, alright. So, in vitro is when you perform the experiments in the laboratory, okay. You have a device, you take the cells, you grow the cells, study those cells, use different drugs to understand how the cell's property would change, all things are in vitro, okay. Three terms: in vivo, ex vivo, in vitro, right. So, now we are talking about a probe that will be used by a surgeon during the surgery. So, what should be the modality, or what should be the technique? It is called the in vivo, right, inside the body, in vivo. So, if you have the probe integrated with certain modalities that can be used, and when you touch this area, it can tell whether it is normal or it is cancerous. It is normal or it is tumor, right. Now, there is a question that what is a tumor boundary or where is the tumor boundary, alright. It is an extremely hot topic. While learning all these things, if you are also doing your research, you are doing your PhD, you can think about finding a solution that can be implemented to understand or to identify the tumor boundary. Very interesting problem. Okay. So, not only to identify this still there is cancer or not, but also to identify tumor boundary, but let us not talk about tumor boundary right now, we will talk about just cancer or not. So, can you give a doctor a pen that can be used for identifying normal or tumor, or there is just it is normal now, the surgery is done successfully. Okay. So, there is something that we are working on, we have a collaborators, we are working on that. Now, when I talk about this all these technologies, right, whether it is electrical or whether it is thermal, whether it is mechanical, whether it is ultrasound, which is acoustic, right, I will be teaching all these modalities and corresponding sensors for these modalities. So, let us not worry about how these sensors are fabricated, we will talk in depth in the other lectures. Okay. So, let us come back. What you see on the slide? What you see is that the next part is the oral. Okay. So, oral is oral cancer, oral cancer. Now, oral cancer is again extremely what you call deadly disease, and it has a huge numbers, particularly when you look into India, right, or India concept or India as general, then you understand that the northeast, right, that region has a large cases of oral cancer. There are several regions, there are several reasons, of course there are other regions also in our country where there is a huge data which shows that people from certain region has a higher cases are the cases are very high in the certain region for oral cancer. Many reasons, many analysis, hypothesis, but some things are like tobacco is one of the culprit, right, how it is given in the literature or the advertisement, right. Cigarettes or betel nuts, right, and other things. But the problem here is that how you can identify this oral cancer quickly and the technology can reach to the last person, right. Somewhere in the remote village, can you take the technology and can you tell, oh, some person has some kind of inflammation, some kind of irritation, there is a patch, right, there is a burning in certain region below the tongue, right, on the floor of the mouth, right, on the inside the cheek area. So, how, right, which is cancer or not, it is just some kind of other inflammation, other infections, right. So, right now what are the techniques? The technique is you take the swab, take the swab and you send the cells to the remote pathologist. Now, remote is what remote, because you send it to the pathologist who is in the tertiary clinics, and then the swab, the cells, because you take the swab. So, the cells from the swab are taken and smear on the glass slide. Glass slide smearing means spreading of the cells on the glass slide, and these are done after doing a staining called HNE staining, HNE. So, what the pathologist will look into? The pathologist will look into different kind of parameters. One is cell to cytoplasm ratio, double nucleation, right, and several other parameters. But in our term, right, or in our understanding, we should understand that the morphology of the cells would change from onset of the disease to the progression of the disease. Okay. So, if we can identify the change in the morphology using image processing, and certain times the pathologist would miss if there is a small change, but the image and the AI would not miss that part. So, can you bring the artificial neural network along with the lot of images to train the system to identify if the cell is changing its morphology, and a change in morphology when the pathologist identifies, if pathologist can identify a pre-malignant, the malignant is cancer, pre-malignant is a pre-cancer. Cancer is kind of easier way to identify because there is a certain parameters that would definitely change. In pre-cancer it looks kind of normal, so certain times the pathologist, even the expert pathologist, misses it. And how I am claiming all these things? Because we have a collaborator from Majumdar Biomedical Foundation, and we have clinical collaborators, a pathologist on board who does all this work. And we also submitted a paper, it is published, you can see that. The point is that there is a gap of pathologist not able to identify the pre-malignant cells, okay, pre-malignant cells which are pre-malignant in nature. So, if, and then there is a histology of course, right, and if there is a histology you can train the system so that you can identify these pre-malignant cells. So, image processing plus AI is one thing, but then how, I say that you want to bring the technology to the last person, right, say in a village. So, can you have a system just like a microscope, and can the ASHA workers, right, aggregated social healthcare workers, right, these are the most important, right, personnel in the healthcare system, in the healthcare chain, right. Of course, we say that the surgeons and clinicians and all the engineers and scientists and lot of social workers, but the most important according to my understanding of course are the other layers, but the connect with the common people, with the last person is done by the social workers. So, if you strengthen them by giving some kind of technology that can be easily used by a semi skilled personnel, right, then it will be really interesting. So, what if you can make a microscope and give the microscope or keep the microscope there in the village, and the ASHA worker can take the swab, can stain with HNE, can put the slide, it is easy, okay, it is not so difficult for the semi skilled personnel to do this much, and press a button. After putting on the scanner, press a button, the scanner will scan entire image and will identify those cells which are morphology which has changed its morphology, and those images only can be sent to a remote pathologist, and a remote pathologist will say that yes, it looks like atypical. So, the diagnosis is not cancer, okay. The cell, study of cell is called cytology, study of tissue is called histology. So, when you study the cells, right, cytology is still not a gold standard, it is a screening technique, it is not a gold standard. Histology is a gold standard, but study of cells is faster, is easier, right, because you just take a swab, that is it, right. So, if you have the technology right at the village like a microscope with an auto scanner and can get images can be sent, only the one that looks like atypical, that means the morphology has changed, to the remote pathologist for quick diagnosis, that will be a nice contribution from an engineering perspective to the clinical perspective, right. That is what we call clinical technology development, right. Now, another important solution that you can bring is, can you again develop a probe? We are not moving away from the probe, is not it? Can you develop a probe and that can be used by the semi skilled personnel to be used within the mouth, within the cavity, oral cavity, okay, and you just touch the probe, it will tell whether it is cancer or not. There are certain tools which are right now in the market, but we can identify a small, even a smaller change, right, by using a certain modality. Okay. And I am not going into detail of that because it is a research problem that we are addressing, right, until we have some interesting data of which I am confident about. I will not like to just keep on talking on that particular research area, but for other area that we were talking about until now, we have a lot of data to back up the claim that we are making. This one also we know that we have a solution until we just get some data, right. I hope that by the end of this course I will be able to surely tell you that okay, this is the technique by which you can identify the cancer and non-cancerous region in the oral cavity. Okay. Now last two things in the organs that we are targeting in the laboratory. The next one is ear. Ear. And since ear, right, is associated with brain, everything is associated with brain in a way or two, right, directly, indirectly. We will be talking about the ear and the corresponding gaps that we have identified in case of the hearing screening, that is called neonatal hearing screening. Okay. So, if you understand, all the babies, right, have to go through a technique or a screening technique called a BERA or ABR in a right term. ABR is auditory brain response. So, to understand whether a baby can hear or not, there is a tool called BERA which uses ABR to identify that baby can hear or not, a neonatal hearing screening technique. Cost is around 14 lakh to 15 lakh to 20 lakh, but almost none of the primary health centers has this system. That means the babies who are born in villages, they do not go through the screening technique. If they do not go through screening technique, that means when they are only 2-3 years old, their parents would know whether a baby can hear or not when they are 2-3 years old, and that will affect the cognition, right, because hearing is important for the speech development, hearing is important for the brain development. So, the overall the cognition may get affected. So, we are working on that, and I will go into depth as a part of this course, this particular problem and the problem on the different application, different diseases of the brain. So, moving to, so I am not talking more on this problem right now because we are going to learn about it. But moving to the other part, which is the protein. So, cytology we have already discussed. If you see the screen, right, I just talked about cytology with respect to the probe that we are developing for the oral cavity, right, is not it. So, we will, so this oral cancer we have talked about probe, but the same swab when you take it, it can be used with the cytology tool which is right over here. Okay. Now, let us talk about the next device that we work on or we have in the lab, which is focused on the protein-protein interactions. Okay. Protein-protein interactions. So, what is protein-protein interaction? Now, when there is, let me give an example, when there is a oral cancer. So, oral cancer like any other cancer can be primary or secondary, right, primary or secondary. That means it is either metastatic or it is non-metastatic. It is non-metastatic. What is primary, what is secondary? If the cancer is invasive, see you also call invasive or non-invasive. Okay. What is invasive? it will invade the other region of the other organs of the body. It will invade, invasive. Non-invasive means it will stay at a certain region, stay at certain place. Okay. So, primary, secondary, invasive, non-invasive, metastatic, non-metastatic. Okay, same thing, most of the things are kind of similar. At least from your perspective, to understand that when there is a metastatic, means when the cancer will spread through the lymph node. So, there are series of lymph node LYMPH, right, MPH. I hope that when you learn these new terms, you also go and Google it, that what are lymph nodes, right, and you will understand what are the lymph nodes in human body. These lymph nodes are responsible for our immune system. Okay. Lymph nodes are important for the immune system. So, what happens is that when there is a oral cancer and when the cancer is metastatic, that means metastatic or non-metastatic, right now if there is a oral cancer, the surgeon will take out the series of lymph nodes are present here, they are present here, right, and they are present next to the leg. So, you will just understand when you right now lymph node you will see. I will try to show you the where exactly lymph nodes are there in a human body, but the point is they will take the series of lymph nodes out to check whether the cancer has spread, is metastatic or not, right, whether metastasis has happened or not. Now, what I said, lymph node is responsible for immune system, but if the lymph nodes are taken out, then the immune system will fall. So, there are certain proteins that are present in a lymph node that will be on higher concentration when the cancer, when oral cancer, in general we are talking about oral cancer right now, is metastatic. That means it spreads to the different region of the body. Alright. So, during the intraoperative surgery within the operation theatre, can you identify those protein in the lymph node? If present, then and then only you take out the series of lymph node. If they are not present, that means cancer is not metastasis and metastasis has not happened, cancer is not spreading to other part of the body, do not take it out, because it will hamper the immune system. Okay. Now, limited understanding about this is again from the clinical collaborators. Okay. So, what we can do as an engineer, we can develop a sensor based on the electrical impedance or based on electrochemical impedance, electrical impedance or electrochemical impedance. So, I will be showing you some of the chips that we have developed in the lab, and please mind it, we are going to understand the some of this equipment that are used for fabrication in our experimental laboratory. You will be given a video of how the system looks like, how the techniques are there, how to gown yourself before you go to the fab lab, and how to make the device out of it. Okay. So, it is not just a theory, it is a part of TA classes where some of the important problems will be discussed, there are experimental laboratories, and then there is also a lot of theory classes. So, the point that I am making is that there is a chip that I will be showing it to you, which has the electrical sensor and electrochemical sensors. Okay. So, we will be talking about that. The other idea of using the similar protein interaction, the protein is antibody antigen reaction. Okay. Now, you understand antibody like why, okay, like how I will explain, and then you see me how I understand the antibody antigen reactions. If you see the screen, I will just show it to you how the antibody you can assume, you assume like antibody is a Y. Can you see the screen please? So, this is a Y, right. So, this is the FC region, this is the AB region, okay, AB region, this is antibody. For me this is antibody, not for me. Generally how it is, like of course you go into detail, it is lot of interesting stuff and lot of bonds are present, but for us let us understand in a very easier way. Now you understand that antibodies like this on a device, okay, on a device present like this, okay, right, and let us say antigen looks like circle, okay. So, if the antigen is present, the antibody will catch the antigen like this, you see. Again there is a reason, okay, there is a certain bonds that are present because of which antigen will interact with the antibodies and get capture on the antibodies. Now if there is a sensor below this one, then you can either measure the impedance, right, which is either electrochemical impedance or electrical impedance. You can measure either electrochemical impedance or electrical impedance if there is a sensor below it, okay. So, there is an interesting concept here which we call as a surface chemistry, okay. What exactly is surface chemistry and why we are talking about that? Because the chip that I will be showing to you, right, depends on the surface chemistry of this particular surface chemistry, because surface chemistry will help the Fc region to attach on the gold electrodes, right. So, now let us assume, not assume, let us see. So, assume that this is antibody, okay, assume that this and this are like close. Now, it should hold like this, correct. We are, why this region Fc region will attach to gold, why? Because there should be certain bonds that should be present on this gold surface, right. Why you are talking about gold? Because the chip has gold, okay. Why chip has gold? Because there is a sensor which is made up out of gold, right. So, you have to perform surface chemistry so that the Fc region will attach to the gold and the AB region will wait for the antigen. This is a protein, antibody is a protein, antigen is a protein, protein interaction, that is what we are talking about, protein interaction. Now, let us understand, if you see cricket, right, lot of you students, right, who are taking this course at least know about cricket if you do not see the cricket, right. And this is an example because majority of the students may have seen, assuming they have seen cricket. So, when you catch the ball generally like at the boundaries, right, generally like a very crude example, but just assume if you catch the ball like this, the efficacy of catching the ball will be higher. If you catch a ball like this, or if you catch like this, if you just put it down, it may fall, you may not get it right, the ball is coming from the top, right. The easiest way is by this. Same thing goes for this antibody. The antibody is not standing straight to hold the antigen, if it is standing like this or if it is reverse, the antigen will not get captured, okay. So, to hold the antigen, to hold the protein, the antibody should be in a certain fashion, it should be oriented in a certain direction, and for that we use something called surface chemistry, in which there are chemicals like pegsilane which are used for the improving the directionality of the antibody so that the antigen can be captured. Both are proteins, so we call it a protein interaction. I gave an example of oral cancer, but we can also take another example of using the S protein and N protein which are present in the COVID. Can you capture those protein immediately onto the chip? If yes, it is a screening platform, right. So, there can be many more examples of this. There is another example of antibiotic susceptibility where we capture the bacteria onto these antibodies again with the gold surface. Now, you again think that why we are not going into advanced neural science, right, for engineers. These techniques are all based on the sensors, and sensors are also used for your advanced neuroscience course, and that is why we are talking about all the possible applications or certain applications. These are not all possible, but certain applications that we are working on, so that I can tell you in detail. Okay. There is something next called antibiotic susceptibility. That means that in there is a bacterial infection called sepsis, SEPSIS, sepsis. Now generally there is bacterial infection, right. We give blood, and then the report comes in 2-3 days, and then we are given a certain topical antibiotics, right, initially. And for the neonates, right, newborns, waiting for 2 or 3 days is a life threatening episode, right. There are certain bacteria which are already present. These are called gram positive bacteria and gram negative bacteria, and out of gram positive and gram negative bacteria, about 15 of them are there, but 8 are present in most of the cases. So 4 gram positive, 4 gram negative. Can you capture those bacteria onto a chip from the blood, okay, from blood? Now blood has RBCs, isn't it? So this blood may coagulate, right. Do you generally take the blood in an anticoagulant, so blood will not get thickened. So what we can do, can we study the or can we understand the presence of this bacteria from the serum or plasma, so that RBC will not be there, right. So how the plasma can be taken? You take the blood, put in a centrifuge, right, revolve for higher, rotate for higher number of rotations per minute, and the RBCs will settle down, the plasma will come up. You take the plasma, and the plasma has the bacteria, you will know probably that the what is the bacteria and what is the concentration of that bacteria using the chip that we have developed. We have done this testing with PBS. We are under we are now using this chip for the blood sample as well. Okay. So this is for the neonatal sepsis. Now why we want to use the chip? The question is why we need to use this chip, because there is a gap that it takes about 2 days for the report to come back when there is an infection in the neonates. Can you reduce the time to, let us say, 2 hours or 3 hours or 4 hours or 6 hours, right. So even 1/4 of the time that it takes from the diagnosis point of view, then you can save a lot of lives of the babies. The next device that we are addressing on, or we are developing, is on the intramuscular drug delivery tool. So you have seen in movies, right, or you may not have seen, then Google EpiPen, EPIPEN. Okay. So and there is, when there is allergy can be of peanut allergy, can be of pollen allergy, can be of milk, right. People have several kind of allergies, and certain people are very sensitive to this kind of materials, and if the allergy episode happens, it is life threatening. They have to rush to the hospital, they have to get treated, otherwise they will die. So to immediately counter this allergy effect, right, there is something called epinephrine, and that is a drug that is used for, that gives time for the people to at least reach the hospital. The way to deliver this drug is by a device called EpiPen. This device, you have to open it. I will show it to you one device how we can use it. You have to open it, take out the device, put in the muscle, right, which is the thigh. You press it again, assuming that, okay, let me just I will demonstrate it later, but you take the device and then put in the thigh, assuming this is a thigh. This is not a thigh, okay, and just giving an example. I will show you an actual demo. So when you press it, then only needle will come out and will deliver the drug that is present in the EpiPen. The cost is $200 to $300. The difficulty is when this episode, person has to open it, take it out, deliver it, right. So there are some issues with that. So we are we have developed in fact some device called EpiShot, EPISHOT, and it has recently won a Dyson award. So what kind of new design that we brought it? We brought a design which will help a patient to open with single hand operated. Now you safety features, there are 3 safety features. Until you touch and press and then you press a button, then only the drug will deliver, otherwise just pressing a button the drug will not deliver. Then the needle will retract once the drug is delivered. So these are some advantages. The important advantage is that it can be reused, and because we have made it here, the cost comes down to 1/4 of the cost of the device that is in the market, right. So there is a drug delivery tool. We are also working on intradermal tools. We are also working on micro needles with a patch that you can put the patch and the drug will be delivered, or you need to understand the needle will absorb or will be bioabsorbed into the body. That means once you put the patch, the needles that are in the patch, these are not steel needles, nope, these are polymer needles, and the material is such that it can be absorbed in the body without causing any toxicity. Okay. This is called advanced research. So we are working on that to deliver a drug just by using a patch. Patch has small needles, people will not feel, there is no pain, okay, because this does not touch the nerve which will cause the pain. So we are working on that research domain as well. Okay. So this is all about the clinical technology development and what kind of research area that we work on. I will stop here, and the next class we will go through the clinical collaborators that we work on, then going to the facilities that we have, and then we start going into details about how different sensors can be fabricated, followed by how these different applications, whether it is epilepsy or Parkinson, and how we can develop device that can be implanted in a rat's brain, how to take the signals, all these things we will be discussing as a part of this course, right. Till then you take care, I will see you in the next class. You can see this lecture in 15 minutes if you want to, right, because sometimes it becomes overwhelming to understand lot of different topics in a short span of time. I will try to keep it as crisp as possible, but I also want to show you that what are the tremendous opportunity that lies in front of you when you understand the technologies that we are working on, and when you learn it you will also see the importance of that. We will keep talking, we will keep discussing. There is a portal through which you can reach us, right, reach the TAs, and we will try to address the queries as much as we can, right. I will try my best to answer most of the things through TA, and I look forward to interesting exchange of ideas. Sometimes you may have a very cool idea, it is really cool, you can send me an email as well, right, and if possible and if I have some solution I can help you out during that time. Till then you take care, I will see you in the next class, and we will talk about the other important research domain. Bye bye.